Hello and welcome to the Y9 options video for GCSE Computer Science. What we're trying to achieve with GCSE Computer Science is to give you a really good understanding and a grounding of computer science, so you can take that into further education and maybe into a job, into industry, and allow you to be at a good point where you can develop your skills. The course contains 8 main subjects, and I've grouped them into the areas below, just 4 areas below that I hope explains this. So the first area is logic and coding, and that includes things such as computational thinking, which is a technique with a set of processes that allows you to develop computer programs and systems. We also would have a look at developing your skills further in Python. So we do some coding and we use and continue with Python. Python is used in industry and it's an industry standard language. So that's why we use this, and we'd look to be developing your skills in this particular computer language. We're also going to have a look at data and data representation. We're going to try and understand how data is used within computing. So firstly, we'd have a look at how data is used in things like sound and images, and how we can translate that data to be used in those 2 particular areas. You've done a bit on this at KS3, and we'd try and develop that further. We'd have a look at databases. And we'd be looking at those in depth and various database tools that you could use and how you could structure a database and be able to use languages such as SQL. That is a really good, strong computer language that can be used to interrogate a database and to get the data that you need. We'd be looking at computer systems, and we'd be looking at hardware and software and how computer architecture works. We'd also be looking at the computer systems for things like the internet and for the cloud and for networks. So you'd get a good understanding of those sorts of computer systems also. And then the final area is human-computer interaction, risk and effect. And from that, what we're going to be looking at is things like cybersecurity. So we want you to understand the various aspects of how computers can be secure and how they could be endangered in some way in terms of things like privacy. And we try and allow you to understand how computers can be affected by things like hacking and those various things. We'd also take a look at the ethical issues and the legal and environmental impacts of computers and of digital technology. And that's a more softer area of the computer curriculum. You can see with these 4 areas, what we're trying to do is give you a good rounded understanding of computing. And it's a little bit more difficult than KS3, and we want to try and give you more information in depth. Right, what we're going to do now is talk about what sort of character and what sort of person needs to be involved in computing.
Thank you, Mr. Beale. A sterling introduction there in terms of computing. Now, what are we looking for in terms of our children, and ultimately making sure that you can be successful in terms of computing? The first thing I'll say is you don't need to be a master at programming. You don't need to be somebody who spends a huge amount of time programming outside of the school, able to write your own software, etc. However, you do need to be willing to work hard to pick up those skills. So yes, you may not be able to write kind of programs 100 lines in length. However, you do need to be willing to put the work in to make sure that you can learn how to write some fairly basic programs. And a GCSE computing program is possibly anything from kind of 5 lines up to 20-25 lines in terms of coding, so willingness to learn new skills. As part of that, you will make mistakes, you will get it wrong, so we always look for our children to be willing to get stuck in, really, when it gets tough, when it gets hard. People who are willing to get stuck in, continue to work on things and not kind of give up easily. So we like our children to persevere. You do need to have a logical brain and be able to think about things logically in a kind of fairly simplistic fashion, but be able to take about problems and think about them in kind of component form. There is a lot of content within computing, so it's really important that you've got a good working memory. There's a lot of subject knowledge in computing. It's really important that you're able to remember things. And then finally, you need to be able to add up. You need to be able to add up the numbers, and the numbers on the screen there. You've got 1 + 2 + 4 + 8 + 16 + 32. If you're going to do computing, you're going to be successful, you need to be able to add up those numbers fairly quickly, but more importantly, accurately. So you can use all the techniques that you've learned in maths. It's really important you can add up those numbers there, and those numbers could go all the way up to 128, so 32 plus 64 plus 128, and you need to be able to add those numbers up. In terms of multiplication, you need to be reasonably good at multiplying by 16. Hexadecimal is the number system that we look at where you need to be able to multiply by 16. So it's good if you can multiply, by 16, however you do that, whether it's, on the example there, 16 times 10 plus 3 times 16. That's how I do that one. So 16 times 10 is 160. 3 times 16 is 48. I'd add the two numbers together, and that's how I'd get my answers. So that's what we're looking for in terms of our pupils: a willingness to get stuck in and learn new skills, the ability to persevere when things are hard and keep working on solutions and not just give up, being able to solve things logically, methodically, and go through things in a particular order, good working memory, and able to do maths at a reasonable standard. Jobs in careers in computing. The world really is your oyster here in terms of jobs, and there is a much wider kind of group of jobs now than perhaps there ever has been. So if you want to write software, you could go and write the next Fortnite or the next massive computer game. If you want to be an analyst is somebody who goes away and looks at a problem and kind of find a solution for a problem, and then they'll propose that to someone like a coder. In terms of that, you might want to go into cybersecurity. You might want to write kind of software that helps people with cyber problems. You might want to test systems in terms of security to make sure that they are cyber secure. You might want to create content for the web. You might want to create mobile apps. The list is literally huge. In terms of pay, if you're looking at a career in computing, it depends on the job. It depends where you are in the organization. But there are some really, really well-paid jobs out there. So I'd strongly recommend, having a look out there, seeing what you want to do, and picking up those skills that are going to enable you to go into those jobs, because computing continues to be hugely popular. It continues to be a really broad kind of area in terms of work. So loads of jobs, loads of careers out there. Please, please, please do give it a go. In terms of the course, I know Mr. Beale spent some time talking you through each of the different topics within the course. I just thought I'd tell you a little bit from my perspective as somebody that's taught this for a number of years. Firstly, programming. We talked about programming. We said programming is a big part of the course. It's probably 40% of the course. So in terms of the way you are assessed on your programming, you will ultimately be asked to write programs on an exam paper in 2 years' time after you've done lots of work with us, and you might be expected to write 5 or 6 different programs on that exam paper. So it is important, after all the time you have with us, that you are able to write code, albeit on an exam paper in response to some questions. Algorithms are the bit that comes before the programming. So in other words, an algorithm is the bit that we write before the program that tells us how to solve the programming problem. So it's really important that you're able to think kind of strategically, think logically, and come up with solutions to problems. Binary is worth about 10%, so your ability to understand binary numbers and convert numbers from binary to decimal, decimal to binary, and also hexadecimal, as well as a second number system. Hardware is typically worth about 10% of the course. So this is how computers work, what the components in there do, what the CPU in there does, etc., is a reasonable percentage in terms of the worth of the course. But that was something that we do with Year 7. Boolean logic is 10%, so looking at how circuits inside computers work and the maths going on within the computers. That's something we do in Year 9. And cybersecurity. Cybersecurity is the really interesting one that everyone generally really enjoys. So looking at strategies used by hackers to attack systems, test systems, all of those sorts of things. Again, that's something that we do with Year 7. The last one is the ethical, legal and environmental issues. This is to do with computing and ultimately the impact of computing on the workforce, the environment, the law, etc. So this is looking at computers and the law and how ultimately they impact upon the law. So that's the content in terms of the curriculum. So it gives you a bit of a flavour of what you might be doing. So yeah, in a lesson, in a week where you have 8 lessons, you might typically spend 3 or 4 lessons on programming. So it is important, it is a big part of the course, but it gives you a bit of a flavour there in terms of what you'll be doing as you move through the course. Final slide from me is about how you'll be assessed if you do computing as a GCSE. Computing is 100% exams. There are 2 exams that children take, both at the end of Year 11. One is the programming paper and the second one is basically everything else. So binary, hexadecimal, hardware, cloud storage, networks, cybersecurity, logic circuits, lots of the things that you've done already, but albeit at a slightly higher level than you perhaps have done already. It is a 100% exam. You do need to be able to remember things. You do need to be able to recount information. But yeah, it's assessed at the end of Year 11. Come along, talk to Mr. Beale or I, ask us any questions if you've got any questions about computing. The curriculum that we do in Year 7, Year 8 and Year 9 is really to set you up in terms of GCSE computing and make sure, should you want to do this in Year 9 as an option in Year 10, that you're ready to go. So yeah, if you are curious, if you're willing to work hard, if you're willing to get stuck, learn those new skills, etc., come and talk to us. Come along to the taster, have a conversation with us. Good luck. Thank you.